Newport University. Thank you for joining and listening in. I'm very happy to be part of this MOOC session on visual literacies. Today is Thursday, November 1st, 2018. Today I'll be talking about video for calculus, explaining these video assignments that I institute in my mathematics classes, in my calculus classes, and to explore some of the background and content of how these teaching techniques fit into the overall idea of enhancing visual literacies. Just a quick outline of my presentation of this webinar. Well, first of all, I should say thank you to the organizers of this MOOC, Julie Ann Syme and Carissa Themelis. I'm very grateful that you asked me to participate. Hopefully I do a good job. This is a great idea, and I'm glad that we can reach out to so many other educators around the world. So, well, first of all, I'll begin by discussing these video assignments and what they are and how I use them and how we can create and establish them in courses, maybe not just in mathematics courses, but different types of settings. And then I'll talk a little bit more about their context, how these video assignments in educational theory can be considered effective homework practices, and I'll go into a little bit more detail about what that means. And then I'll offer some final results and some reflections about my own experiences with these video assignments. And then I will open up the webinar to some question and answers and discussion from any of the users listening in a live format. Well, first of all, a little bit more about me. So again, my name is Matt Morena. I teach at Christopher Newport University. This is a small liberal arts college on the eastern coast of Virginia. This is a public university, so this is a four-year institution. It's fairly small and quaint. We have around 1,200 students. Here's a screenshot of our very pretty campus, just to give you an idea of what size classes I typically teach. I usually have around between 15 and 25 students in my classes, and we offer undergrad degrees, Bachelor of Arts, Bachelor of Sciences in our classes. So more about these video assignments. What are they? These are exercises in which I ask my students to create videos of themselves teaching the solution of a calculus problem to their classmates. So usually students will film themselves, record themselves using their smartphones or their tablets, sometimes even a GoPro camera. But the point is that their job is to work through and demonstrate a solution to a challenging mathematics problem. Once students have created these videos, then I assess the videos for quality and for content. And then I post them to an unlisted or private YouTube channel that my students can tap into, and so that they can learn from each other's videos. So for instance, here is a screenshot of one of my students about to demonstrate a calculus problem, and you can kind of see just what this looks like. So we have the student who's going to teach a solution to the audience. For those of you who are more interested in this teaching technique, my co-authors and I, Shelley Smith and Robert Talbert, have recently published a discussion, an overview of this teaching technique in the journal Primus, which stands for Problems, Resources, and Issues in Mathematics and Undergraduate Studies. So this link here is clickable, as are these two thumbnails. And so if you're interested in learning more about this teaching technique, please see our article. For me, this idea came to me a few years ago, where on a course evaluation from a student taking a sophomore junior level class in linear algebra wrote that the class was a giant struggle for this person specifically because of the so many wordy and abstract definitions. The student would prefer numerical examples and a way to kind of learn the material outside of class, a little bit more than just being confined to the in-class learning. This got me thinking of ways that I could move some of the content outside of the course, outside the classroom, to get my students a little bit more engaged and offer them more independence and responsibility in their learning. So in this context of these video assignments, specifically for calculus, students will create and share videos of themselves as they demonstrate and teach solutions to a problem that they choose onto their classmates. In this setting, students can kind of share and develop their own vocabulary and offer their own perspective on these problems with their classmates. And also, students will have the opportunity to choose their own problem that aligns with their interests, rather than having the instructor kind of give them problems specifically. Here students can choose, can self-select problems that they're most interested in. From the instructor's perspective, these video assignments also offer us a wide range of objectives and ideas that we want to institute in our classroom. So for instance, this gives us a way to deepen a student's understanding from a procedural to a conceptual level. So to give opportunities to students to form a more intuitive and a deeper understanding of a topic or a different type of problem. And also to try something fun and interactive to engage with students outside the classroom. This also gives us a chance to bring technology into the classroom, whereby students can use their smartphones and GoPros and their tablets, etc., in an educational context. This also gives the educator, the instructor, a way to develop a student's communication skills, so in particular their written and oral skills. And finally, particularly in online courses where it's very difficult to establish a sense of classroom community, now instructors can bring the different students together. So these videos offer a way to put a face to a name and see the students' personalities and hear them speak and hear them teach a solution to their classmates. So here's this slide gives us a step-by-step overview of these video assignments. So first of all, the instructor will prepare a list of the calculus problems from which the students get to choose. So once students select a problem, then it's up to them to create a video in which they teach the solution to their classmates. And I'll talk a little bit more about this process later on, but once students have created this video, then they can upload the videos to a private and secure website, such as YouTube, that the instructor creates. Then it is my responsibility to assess and evaluate these videos for content and for quality. And I'll talk more about this rubric later on. But once I have evaluated these videos for their quality, I then will make these videos accessible to the class so that students can learn from the videos and see their students teaching their solutions to each other. And the idea is that this not only conveys a sense of community in the classroom, but allows students to really get to know their type of problem and their solution, and also to teach it to other classmates so that they can in turn learn from each other. A little bit more on what I look for as the instructor in these videos. I ask my students to keep their videos under 6 minutes in length, just so that the videos are a little bit more manageable. This also keeps the length of the videos within a reasonable attention span for the students. And it also kind of forces the students to really think about and plan how they want to showcase their solutions. So these problems that I provide to the students to choose from are intentionally chosen so they can accommodate solutions in under 6 minutes. And it also makes students be very aware of what their solution will look like and make them very careful in how they plan their solution. So this 6-minute time limit really forces students to think about how they want to demonstrate their solution and how they can really just focus on the important pieces of the solution in order to keep everything under 6 minutes. I also mandate that a student's face, voice, and handwriting should be in the video at all times. This is also a way to confirm that it really is this particular student who is performing the video rather than someone else, rather than a surrogate, to keep everything in-house and authentic. I don't employ a points system when I assess and grade these videos. Instead, I grade them on a pass, no pass assessment. And I'll explain, I think on the next slide, what I mean by pass or no pass. But I allow students to resubmit any video that doesn't earn a pass on the first time around. And I also want to just point out that I want these videos to be filmed in landscape mode on their smartphone. This ensures that the smartphone camera captures the entire screen when the recording is happening. So more about this pass and no pass rubric. So when I pass a video, I do so if it has the correct final result, so the correct answer. And just as a side note, these problems that I offer students to select from, these are usually odd-numbered problems in the textbook. And these odd-numbered problems in the textbook usually have the answers, but not the ultimate solution, found in the back of the textbook. So this way students have the answer in front of them, and that can kind of direct their solution to get to that answer. This gives students a sense of direction as they formulate the solution to their own problem. Also, a pass video doesn't contain too many major errors, other than maybe a few minor arithmetic errors. I realize that these students are undergraduate students; they're just learning the material for the first time, so there should be some sort of leeway as far as what kind of mistakes they should be allowed to make. I want to make sure that these videos offer a clear and persuasive reasoning. Remember, the objective is for students to teach their solution to their classmates, so their explanation should be clear and easy to follow. Well, good. Well, welcome to the user from Finland. I also want to point out that these videos should adhere to the guidelines I stipulated, so they should be filmed in landscape mode, another 6 minutes in length, and so on. And there shouldn't be any issues with the video or audio quality of these videos, right? So I should be able to see the student well enough, the image shouldn't be pixelated, and I should be able to hear the student well enough that the audio comes through. There's not too much background noise. Another example is that the student's handwriting should be very clear and legible. And again, if a student's video doesn't pass, then I usually give them 3 days to correct and resubmit another version of their video. To give you an idea of how these videos might be used in a semester-long course at my university. So here's an example of a course template in which there are 3 tests and a final exam. I usually space these videos out so that there's one video assignment due about halfway in between tests, and then another video that's due just before a test. And then, of course, there's a video that I usually have due right before a final exam. Having a video assignment due just before a test offers the students a way to kind of review and study and prepare for the test. Offering a video assignment about halfway in between tests kind of challenges students to keep up with the material and forces them to review the concept so that they are following along with the course. I'll explain later on what I mean by these introduction videos. Essentially, these are a way for students to learn how to use the video software and how to upload videos online, and also to introduce themselves to the class. So again, to strengthen class community. When I prepare the list of mathematics problems that I'd like students to select from, there are a variety of ways to do so. A simple survey would work. Posting the problem list on a website or on Blackboard or Moodle or Canvas would also work. But I use Doodle, which is free and is very user-friendly. So on the left-hand side, here's a screenshot of what the Doodle homepage might look like. So you can see that I prepare effectively what is a survey to my students. And so I offer a short short narrative of the instructions for what students should be expecting to see in the purpose of this Doodle poll. And then I can very clearly list the problems that I'd like students to select. So again, you can see that these problems are usually they are odd number exercises from the textbook, and the odd number exercises from the textbook usually have the answers printed in the back of the textbook. So the odd number questions are deliberately chosen by me so that students have the answers in front of them. So once I prepare this list of problems that students select from, then students will take this Doodle poll, and this is what they will see. So this is from the perspective of the student. So they'll see this short narrative in the beginning, basically the instructions for the Doodle poll, and they'll see the list of problems, the list of problems that are available to the students. And this way they can see which problems are available and which problems are not available. So if some other student has already selected a problem, that particular problem is grayed or shaded out in the Doodle poll. But if a problem is still available, then a student can see that problem is available to select. I've blackened out the names of the students here for confidential purposes, but you would see a student type their name here. They can also see the other students in the class, the names of the other students in the class, and they can see which problems are still available and which problems have already been taken. So from the instructor's perspective, this is how I assess these videos. So assuming that a student has already posted and uploaded a video, I see that, and my first criteria is to make sure that the video is under 6 minutes long. If the video isn't 6 minutes long, or maybe if there's some leeway, then I offer the student some feedback and a chance to redo the video and ask the student to repost the video. Next, I make sure that the video is clear, both audioly and visually. So can I hear the student well enough that I believe other students can understand the student? Can I make out and understand the student's handwriting? Is there background noise? Is the video pixelated? Is it high definition? If so, then I move on and assess the video more for content than just audio or video quality. So is the solution correct? Is there maybe just one or two sort of arithmetic or minor errors? Is the solution easy to follow? Do I expect that other students could learn from the solution? If so, then I pass the video, and then I will post this to the sort of repository, to the main website for all the students to see. So here are some screenshots that I have taken from my students' videos. So here's a screenshot of a student demonstrating a problem in Calculus 1. So usually the students find a nice quiet space on campus with which to work. Usually there's some sort of whiteboard access that they have. And so here's a Calculus 1 problem. For those of you who teach mathematics, looks like this student is demonstrating a integration by parts type of problem. Here is a multivariable problem. So again, the student is demonstrating a solution on a whiteboard. Here the student is making use of an empty classroom. And again, the whole purpose of these videos really is for students to understand their solutions well enough that they can teach their solutions to other students in the class. Now, just to kind of demonstrate that these type of videos align well with what other researchers have called effective homework practices, let me point out that recently in 2015, there was a paper published by Ellis, Hansen, Nunez, and Rasmussen in the International Journal of Research in Undergraduate Mathematics Education that looks at what the best undergrad institutions do for effective homework practices, and they're able to quantify a good homework assignment according to structure, content, and feedback. So an example of a good homework system in a particularly effective undergraduate mathematics program typically assigns and collects homework more frequently than at other institutions, also offers students to work together in groups, and it also uses online homework more frequently too. In terms of content, an effective homework assignment or an effective homework problem usually distributes evenly procedural and conceptual homework questions. So procedural questions might be more mechanical, offering students a way to kind of follow through a method step by step, whereas a conceptual homework question, there a student might need to rely on sort of an intuitive or a visual understanding of the topic or the content. This also requires students to think and to explain their thinking more often. And one way to do this is in the context of challenging word problems. So mathematics programs that follow these guidelines are really establishing an effective homework problem or effective homework system in terms of the content. Finally, the particularly effective homework systems offer and return graded homework assignments more frequently than the less effective homework programs. So this kind of asks instructors to provide feedback quickly and efficiently to the students. And this is very effective because receiving quick turnaround time is important for students to figure out, what are they doing right or what are they doing wrong. These video assignments align well with these effective homework practices. In particular, they are very interactive. They incorporate technology. There's this online component to them as well. When I assess these videos, I offer very constructive feedback to the students. I really like it when you did this in the video, or I would have preferred it if you had done this instead in the video. This builds this community. It's a little bit more progressive, a little bit more innovative. It allows students' personalities to really shine through in the videos and be creative. Let me just quickly reflect on my own experiences with these video assignments. And then we'll look at a few more screenshots of these video assignments, and then at the end, I'll open up this session to Q&A from the participants. So I have used these video assignments in a variety of different levels of math classes, beginning with a sort of lower level calculus class up through an intermediate calculus 2 class. So here the students are more sophomore, junior level, and then on up into an upper level and even an advanced level differential equations class. And I find that these video assignments are particularly suited and particularly effective for the lower level math classes, so for Calculus 1, for Calculus 2, and for some multivariable Calculus 3 type questions. This is because these types of questions at this level of mathematics can really be solved in under 6 minutes or less. They're fairly intuitive. Here the students are really sort of learning the material and really looking to become engaged with the material and their classmates. I find these video assignments aren't as suited or aren't as effective in the upper level classes, usually because these types of problems, the solutions require maybe more than 6 minutes, maybe more than 7 or 8 minutes to really demonstrate. Here the problems are a little bit more time consuming and a little bit more challenging. So these types of problems don't really lend themselves well to these video assignments. And I found that in differential equations, here the problems usually take upwards of 10 minutes or so to complete. And so that's not really appropriate for these video assignments, in my opinion. So again, here's a screenshot of a student demonstrating a solution in a differential equations class. This particular video actually lasted over 10 minutes. You can see that it requires almost pages and pages of formulas and integration steps. And really these types of problems are bring in a whole range of courses. So differential equations, here it relies on Calculus 1 and Calculus 2 material, as well as maybe Calculus 3 and maybe even linear algebra 2. So these types of problems are very, very involved, and they're very, very difficult to force students to teach solutions to in under 6 minutes. Multivariable calculus questions, here they're a little bit more suited, but some of the problems can be very in-depth and very long. But students still found these video assignments very worthwhile, I think, because again, they get to take control of their learning and demonstrate the solutions to their classmates. Calculus 2, I think, is particularly well suited to video assignments. Here, many of these problems they range in difficulty, but many of them can be solved in under 6 minutes, and the solutions can be demonstrated in under 6 minutes to their classmates. Calculus 1, here we have some of the not necessarily lower level students, but students who are just beginning their mathematics careers. And so these types of video assignments really offer them a nice way to be engaged and positive and innovative in their solutions and in their learning too. So here are some comments from actual student feedback that I have received about these video assignments. Many students really appreciate the video assignments. They find them fun and interactive and innovative. Let's see what else here. It really helps them learn to communicate and brush up on their communication skills. Of course, every now and then you have students who don't appreciate the video assignments all that much, and honestly, I find that these were the students that also had a lot of work and commitments outside of class. So maybe students that were on athletics teams or that had extracurricular or even family commitments. Because these videos are a lot of work, right? So not only do you have to select a problem, not only does a student have to select a problem, work out a solution, work out a correct solution, but then find time to video record themselves teaching and demonstrating the solution to their classmates. And many times these film recordings, these video recordings require multiple takes. Here's some more student feedback. So again, these comments here are kind of alluding to a deeper appreciation or an awareness of the video assignments in general. So these video assignments really teach students to be a little bit, to tackle more complicated problems and to effectively explain them. Many students got into the habit of writing out a script of what they would be saying. that helps them kind of really plan out their thoughts and makes them feel a little bit more comfortable and less nervous behind camera. And also challenges students to really understand the context of the problem and not just how to do the problem. And this illustrates that their learning has progressed beyond procedural levels, maybe onto conceptual levels. But it really illustrates that many students really became aware of how much educators have to plan and anticipate solutions that they're going to demonstrate to their students and to their classmates. From an instructor's perspective, I found these video assignments very, very worthwhile. So for instance, this allows students to make their learning visible. It also moves some of the content outside the classroom. So now students are responsible for actually learning outside the classroom. This gives students a little bit of a sense of independence on their learning, so they get to kind of learn at their own pace for these video assignments, and they end up creating something that they own, right? So it's their video. They have complete control over how they demonstrate their solution to their classmates. In doing so, when I post these video assignments to our class website, this gives students a large library or repository of worked out example problems. This gives students another resource, another avenue for learning, for studying, and for practicing the problems in anticipation of a test or a quiz. And particularly for online courses, this strengthens class community. So I saw even in face-to-face sessions that the students were talking about their videos in class, saying something like, I really liked your video, or I found it funny when you did this, or your video was really helpful because now I understand this concept better than before. As far as an online course goes, I find these videos also very helpful. So for instance, think about how difficult it is for an instructor to administer an online test, a time test, when the students are off campus or working in the virtual world. How do you ensure that this test is proprietary, that the student perhaps isn't cheating or getting help from other resources? These video assignments, I think, accomplish just that, because it's up to the student to create a solution themselves and then present the solution to the camera. So the instructor actually gets to see the student's thought process from start to finish. And making sure that the student's face and handwriting and voice are in the video at all times really lends a degree of authenticity to the problems. Now the instructor can really verify that it is the student that is solving the problem without the help of someone else sitting next to them. Just a few tips from my perspective, from the instructor's perspective. I really advocate creating an initial video that isn't math related or content related. I call these class introduction videos. So these are usually 2 to 4 minutes. They effectively serve as an icebreaker. I give these video assignments out in the beginning of class, where students will introduce themselves to the class, and this also allows students to learn the whole process for these video assignments, how to create and record the videos with their smartphones, how to upload the videos. It also kind of makes students feel a little bit more comfortable seeing themselves on camera and hearing their voice, so kind of alleviating that stage fright. So that way, when it comes time for the students to actually make one of these calculus video assignments, they are already a little bit more comfortable and a little bit more confident. To help with this process, I usually prepare a list of 5 or 10 sort of icebreaker questions. So maybe you can see this, hopefully so, but I ask students to state their name, their hometown, where they're living on campus, their academic majors or minors. I ask students to volunteer what campus organizations or clubs they belong to. I ask students to answer or respond to some fun questions. So what kind of music do they like? What are they currently listening or reading to or reading? What sort of TV shows are they watching? What do they like to do for fun in their free time? If they were to go on vacation, where would they go? What's one item on their bucket list? I think you get the idea, but this gives students a fun way to introduce themselves, and also allows students to really feel connected to the class, because in sharing some of their interests. Now they feel like they have shared a piece of them to the class already. Plus, they get to see other students on camera introducing themselves. So that's why students can kind of relate to other students that may have shared or common interests with them. And I also participate in this myself as the instructor. So I will also post my own introduction video to the class website where I run through the same list of questions. This way students can get to know me a little bit better, and I feel a little bit more, I feel like I relate to the students a little bit more and become a little bit more human to the students now that they know a bit more about myself. So instructors, I encourage you to ask students to create an initial class introduction video, and I encourage you to participate in this assignment as well. So here's an example of a class, of a screenshot from a class introduction video, and students here can be really, really creative. So these two students here, they kind of created this introduction video almost as a talk show. So one student on the left is interviewing the student on the right. So there's a little bit of creativity, a little bit of group work that goes into these videos, and that makes them kind of fun. For the actual first calculus video, where a student is formally demonstrating a solution to a calculus problem, for on-campus face-to-face classes, I have a tip. So I recommend inviting students into your office during office hours and having them perform a dress rehearsal of the assignment. So during office hours, a student come in. You can almost see my whiteboard behind me in my office, and students will come in and they will actually demonstrate their solution as if they were being filmed. So they begin by writing the problem on the board, explaining the directions to the problem, and then solving the problem in front of me. And so at this point, this gives me an opportunity to kind of offer feedback, constructive feedback to students on the fly, saying, you can kind of skip this step here, it's a little bit insignificant, or I want to see this, or please write out this a little bit better. And usually what happens, I'm telling the students to make eye contact with the camera, because I like to see them teach their solutions to their classmates. This also gives students a way to learn my expectations for the assignment, to gain confidence in the process, and to really get comfortable with the whole procedure. And they'll feel confident in their solution, and that helps them be a little bit more confident on camera too. So as a tip, if at all possible, I'd recommend asking your students to come in during office hours and just doing a quick dress rehearsal or a quick practice run through of their solution. No camera, no smartphones, no tablets, no GoPro cameras, or anything like that, just you and the student. And this also gives the students a chance to really get to know the professors at the beginning of the semester too. I also have taken to posting some supplemental documents for my students so that they understand the reason behind these video assignments. So in this screenshot of these two documents here, I kind of go, I kind of mention what these video assignments are, what's the purpose of these video assignments, and I kind of explain to students why I think these video assignments will be helpful in getting them to learn the material better than sort of more traditional paper and pencil assignments. And I explain to them that being able to teach material is not easy, right? Our jobs as educators aren't the easiest in the world, but when you're able to effectively teach something to someone else, and that demonstrates that you really know that topic or that concept well enough to teach it to another person. And so I provide these supplemental documents to my students from the first day to give them an idea of what I expect and why we're doing this and how these video assignments will benefit the students. Along these lines, I also prepare a quick step-by-step process that leads students into how they upload their videos. So this gives me a good opportunity to describe how this process works in general. So first of all, I create a private or unlisted YouTube channel for my class. So an unlisted YouTube channel is one in which all of the videos are private and in-house, so they won't show up on any search engines, but students can still share the links of their videos to their friends and family members, to people that they trust and feel comfortable sharing to. And so this document here walks students through the process of submitting these videos. So once a student has a video already created, they go to the YouTube channel. They will log in with our login credentials. I provide the username and password to the students. They will then upload their video. If they happen to forget to classify their video as unlisted, I can go back as the administrator of the YouTube channel and change this later on. It's no big deal. And then I ask students to maybe provide a little narrative, description of their video. YouTube gives the students a text block in which to do this, so they can describe what kind of solution they are uploading, what kind of math problem they're uploading, maybe give a quick overview of what students will see when they see the video. And then I'm very careful to tell students how to submit these videos, to wait for YouTube to finish processing the videos before closing out of their web browser. And this is very helpful. It also minimizes the amount of questions that I get from students in the beginning of the semester. You know, how does one submit these videos? What is the process? And so I disseminate these documents to students to really help them with that process. For those of you who are particularly interested in these video assignments, I recommend taking a look again at the article that I referenced earlier, Video Made the Calculus Star. Again, my co-authors are Shelley Smith and Robert Talbert. It's just been accepted, but you should be able to find an online copy at the website. Here is the reference to the paper that I referenced earlier about effective homework practices at these effective undergraduate math programs. And here is another article that my colleague Robert Talbert posted on the Chronicle of Higher Education about how video presentations, how these video assignments can help build community in an online course. So now it's been nearly 40 minutes, so let me see if there are any questions that I can field from the audience. So Anna writes, thank you. I particularly like the way you prepare students for videos. Scaffolding is key for them to succeed with their videos. Teachers often forget to give students all the steps. Yes, and I wish I could say that all of this preparation that I gave my students all occurred the first time around, but I've also had to kind of learn and adapt myself. And so I'm sure that there are still bugs in the process that I implement. So if any of you find or have any suggestions for me, that'd be much appreciated too. And let me just comment on a comment that on an earlier comment also from Anna about the pass no pass rubric. The first time that I implemented these video assignments, I used a point system, so where I assess these videos on a 0 to 4 point scale. I found that from the instructor's perspective, this is really hard to implement. It's very hard to attach a numeric score to a video and to say that one video is better than another numerically. And that was one reason for my motivation to switch from my point system to a pass, no pass assignment, keeping in mind that these students or that they are students, and so they're still learning the material, and they haven't necessarily have mastered the material as well as the instructor. So this way, the pass, no pass assignment is very it's a little bit friendlier and a little bit more encouraging than a point system. Yes, so yes, and I agree about the pass, no pass rubric. And then one more comment from Anna, who is from the humanities. So just on a side note, I have also implemented these video assignments in a non-mathematics courses. So at my institution, I will sometimes teach a first year seminar for incoming college students, which is not mathematics at all. It's really a way to help students learn how to be college students, so how incoming freshmen learn to adjust from the transition from high school to college level courses and living on campus and being a college student and meeting the expectations of college faculty. And so in this very sort of non-technical course, I also instituted these video assignments. So for instance, students would introduce themselves to their classmates in these video assignments. We often had a few readings, a few reflections, and this way students could reflect in their videos outside of class, and then we would sometimes watch these videos in class. And so this was another way to be a little bit more interactive and innovative and fun, even in a non-technical and non-mathematics course. So yes, I feel like these types of video assignments could be very well suited for humanities classes. And let me just point out that even over here in Christopher Newport, we sometimes have to cancel classes for snow days, and for we've even had to cancel classes for hurricane days most recently. And so these video assignments allow students to still engage in the classroom, even if there isn't class ongoing. So they can still record videos outside of class, even if class has been canceled. And just another comment from Athanasia. So I'm very happy that you're using these video assignments in your English classes too. Maybe you could share a link to your cooking show videos. I'd like to see what those are about. Yes, let me just comment on Maria's comment. So let me see here. Maria asks, have you seen improved performance in summative assessments resulting from these videos? Yes, I have. Unfortunately, I don't have any rigorous data to show you. It's very sort of empirical and observational, but I have. It's been interesting to see the difference from one semester teaching calculus without these video assignments to another semester teaching calculus with these video assignments. So the same curriculum, the same course, different students, yes, but different instructional techniques. So one course without the video assignments, and one course with the video assignments. And students are much more engaged. They have this greater sense of community within the classroom for online courses and even for face-to-face classrooms. And I've seen them perform much better, again, empirically so, on tests and assessments. So many of the tests that I give in class, I will always include one problem that is either identical to or very similar to a student's video assignment. And so this encourages students to see their classmates' videos, to make sure that they understand their classmates' videos, and it also makes students feel a little bit responsible and accountable for making a good video, given that their classmates will be seeing these videos and trying to learn from them. And yeah, I have seen students really do much better on tests and quizzes, I think, because of these videos, because these video assignments really make students plan their solutions out very formally and very carefully, and it really develops their communication skills, both written and orally. It also encourages students to come and see me in office hours to look over their solution before they post a video on YouTube. So they really want to make sure that their solutions are very, very correct. If I were to compare these to sort of traditional written homework assignments, I find that my students tend to do a much better job because they are really planning out their solutions well, and they really understand the material very, very, very well. They often will spend multiple takes recording these videos so that they learn how to explain something in just the right way, so that everything is spoken nice and smoothly, and that their problem is demonstrated nice and organized on the whiteboard. So Maria asks, are these calculus classes for math majors or are they for non-majors? It's actually a mixture. So in my Calculus 1 and Calculus 2 classes, I see a variety of math majors, but also non-math majors, but students who are still majoring in the sciences. So maybe in biology or chemistry or neuroscience or computer engineering even. I haven't had the opportunity to implement these video assignments in a non-math major or non-science major calculus class. So I haven't had the opportunity yet to actually teach a calculus for business majors or a calculus for the line sciences, um, for life science majors. So hopefully I'll have the opportunity to really test these videos out in other sort of math settings as well. But frankly, I don't see why they wouldn't be effective or fun or interactive or enjoyable by the students. And frankly, let me just point out that if any of you wish to collaborate or if you wish to share experiences or your own tips or suggestions or advice, I'd love to hear them. If you want to take this teaching technique into a more sort of rigorous and formal way, and maybe ask students to comment on the effectiveness of these video assignments, maybe through some sort of survey, and get hard, rigorous, non-empirical data. I'd love to participate in something that we could maybe research and publish that is very formal and very rigorous rather than something that's more observational and empirical. So let me address Maria's question, another one of her questions. So Maria asked about the learning curve for the technical aspects of the video. Um, she's asking about the technical aspects of the video making and if students were willing to invest the time in it. And the answer is yes. So this is good. This is good. Maybe I should have mentioned this earlier. So one of my main concerns as the instructor was what sorts of technical issues my students would encounter making these videos. So I was concerned about technological issues, problems with finding a a quiet room in which to record the videos, being able to use the technology, the cameras, and the smartphones. And I actually didn't have many problems with this at all, which made me very, very happy. You can't imagine how happy I was. Students were usually very adept at using their smartphone cameras. Again, I asked the students to, when filming, to film the videos in landscape mode. So when the phone is horizontal, that way the image from the phone captures the entire presentation and fills the screen. Students who didn't have a smartphone were usually able to borrow one from a friend or to go to our university library and check out video equipment. So for instance, our university library keeps a large collection of GoPro cameras and other video equipment on reserve for students to check out. I was also concerned that students wouldn't necessarily be able to find a nice quiet study space, maybe like an empty classroom with a whiteboard or a blackboard, particularly for students that commute to campus or that live off of campus. And this wasn't particularly a big issue because many students would create their own whiteboards by taking blank sheets of computer paper and taping them to their own wall of their house, and then writing on them and creating their own whiteboards, which I thought was very creative and very effective too. So yes, I did have a concern that the learning curve would be steep for my students, but they surpassed my expectations, and there weren't too many technological problems. There weren't too many challenges with finding nice, quiet study spaces. I would even point out that even many of the adults, maybe the non-traditional students who took my online courses, they were still able to find empty, quiet rooms in their house and create their own wipes as a way to write down their solution on their walls. The only technological issues that my students seemed to encounter was when they would upload their videos to YouTube. If they closed their web browser before YouTube would finish processing their video, then YouTube wouldn't be able to, then their upload wouldn't be complete, and so their video wouldn't upload to YouTube all the way. And that wasn't such a big deal because as the administrator of the YouTube channel, I would see an icon saying this student's video's upload was incomplete, and I could ask the student to resubmit. And that's another bonus of the pass, no pass rubric, and allowing students a second opportunity to resubmit a video that either didn't upload completely or correctly the first time around, or had too many errors in it to begin with. And let me just comment again, perhaps for many of you instructors who aren't necessarily teaching face-to-face classes. So I have taught an online calculus course with these video assignments before, and I feel like the students in that online course really appreciate these videos, being able to kind of have that face-to-face interaction with the other students and with the instructor. Even remotely, I think the students really appreciate that. It makes the students feel like they're really part of a class, of a classroom experience, rather than maybe it's just some icon or just some notice on a discussion board. So students really feel connected. They really feel like they're taking a class that, I mean, it is an online class, but this has more of that sort of classroom feel to it. And even for the non-traditional students, so maybe like the older adults taking classes, they still felt that these video assignments were very worthwhile. In many of these particular video assignments, you could hear, in some cases, sometimes there are kids running back and forth. You could see pets in the background. Sometimes you would see, well, you can really see the students really take to these videos and appreciate this innovative way that the instructor could bring these students into the classroom setting. And like I pointed out, this also gives the instructor a way to really assess how well these students are learning the material remotely. So if you think about it, it's very hard to administer an online test and know for sure that it's that particular student who's taking the test. And this way, the instructor can actually see the student demonstrating the solution and seeing that thought process at the same time. And looking over my notes, one thing that maybe I mentioned or maybe I didn't mention was the types of problems that I selected for my students to select from. Let's see if I can find that slide. Here, so going back to the doodle poll, so I intentionally chose problems from the textbook. In particular, I intentionally chose odd numbered problems from the textbook. Again, this is a mathematics course, but usually in textbooks, usually the answers to odd number problems are available in the back of the textbook. So this gives students a sense of direction for the solution. So they have the answer in front of them, and their job is to kind of fill in the gaps or connect the dots between the statement of the problem and the final solution. So this gives them a sense of direction for the solution and a way to kind of verify that their solution is going to be correct, now that they have the answer in front of them. So maybe what I'll do now is just kind of click through the slides in my presentation again and ask if there are any follow-up questions on any of the slides. So feel free to jump in and ask a question whenever you think of one. So Athanasia has another comment, and I agree with her. So she says, um, so I'm sorry. So Athanasia says it seems like these video assignments create a comfortable, fun, and non-stressful experience compared to the traditional go to the board in front of everyone feeling, especially in math courses. And I couldn't agree more. So students feel they don't have that sense of pressure or that sense of stage fright. So even in my face-to-face classes, I will try to encourage students to go up to the board and present their solutions to the class. But you can very quickly see students that are very uncomfortable, very unconfident, very unsure of themselves. And what I really want to assess is their thought process, how well they know the solution, and how well they are able to communicate that solution and the thought process to other people. And so giving students more control over this process, more responsibility, and more independence really makes them feel less pressured and maybe less nervous and less anxious to make these presentations because, well, I mean, they're filming these presentations in the comfort of their own home, of their own apartment, of their own dorm room, or maybe an empty classroom or a room in a library. And so they don't necessarily have that sense of anxiety or pressure of the other students watching them or their instructor watching them. And just a follow-up comment with that, being able to resubmit a video, I think is important because it allows students to kind of correct their mistakes and improve the quality of their work. But they also eventually realized that resubmitting and creating a new video does take a lot of work. So this really encourages students to really plan and really write out their solution very carefully from the beginning so that they avoid having to resubmit a video, but they know that they have that option if it comes to it. So I'll move on to the next slide. So again, here's the article that I recently wrote. I'll be glad to share preprint copies with you of this paper if you would like one. But there are other articles out there that I believe also discuss the effectiveness of video assignments in classes. And let me just point out that another added bonus of these video assignments that maybe the students quite don't understand is that it also increases the amount of sort of academic connection that I have with the students. So not only are we working in class or maybe during the online component of the class, but students, almost like a homework assignment, they will spend quite some time, quite some effort making these videos. So it kind of, in a very sort of under the radar way, increases the students' exposure to the content. So they get exposed to the content in the in-class sessions or maybe in the online hour or two that the class is held, and then they are learning outside of the class too. So it also brings in a flipped classroom component as well into the classroom or into the course. So a few of you have asked about the article. I believe the article requires some sort of access, some sort of, let's see if I can even bring it up on the screen. Well, I probably won't be able to, but yeah, I believe you might have to subscribe to the journal. But if you send me an email, and again, my email's at the end of the presentation, then I believe I should be able to offer you a preprint copy of the article. So basically, essentially, what my co-authors and I typed up and submitted to the journal before it was edited and before it was published. Let me advance to the next slide. So again, please, if there are any questions, please feel free to chat your question at me. While we're on this slide, let me just explain what I mean, again, maybe about issues with video or audio quality. So in many cases, a student would be writing on a whiteboard, for example, and the actual marker ink wouldn't be dark enough to be able to see the student's handwriting on the screen. And even though the student might be explaining the solution very well, and the answer might be correct and well planned and well thought of, if the audience can't see the marker on the whiteboard, then I wouldn't be able to pass the video. And unfortunately, that meant me asking the student to resubmit the video and not earning a pass that first time around. There are also a few times in which the student's audio from the smartphone camera would pick up quite a bit of background noise, and that made it very difficult for other students to hear the solution in the video. And so that's another one of these sort of technical issues that are really sort of specific to the student and maybe their smartphone that I would have to ask the student to resubmit a new video to. I haven't really commented yet on the types of math problems that I ask my students to solve or to select from. And here the instructor has a lot of freedom, right? So the instructor can make these problems as challenging or as introductory or as fundamental as the instructor wants. And so usually I'll keep the difficulty level of these problems to a level on par with a regular traditional written homework assignment. Every so often, maybe right before a test where I feel like the student's understanding is very solid and they're very comfortable or confident, then I will intentionally select problems for the problem list that are a little bit more challenging, maybe a little bit more conceptual in their nature, maybe a little bit more interdisciplinary. Many times I will select word problems. So it really asks the students to think deeply about their solution and really ask them to bring in all the different perspectives and concepts in the class. And usually the last video problem, the last video assignment that I do towards the end of the semester, right before the exam, will be one of these sort of interdisciplinary, conceptual, sort of word problem level of difficulty in the problem list. So I really ask students to really use all of their knowledge and creativity up to that point. And so this slide, again, illustrates how I disseminate the problem list to my students. Again, I use the Doodle poll, so the link is doodle.com. It's free up to a certain number of students. It's very user-friendly. At one point, I tried preparing a list, just posting a list of the problems on our Blackboard or Moodle or Canvas website, and that was kind of a hassle because I wanted to make sure the list was constantly updated. And that required me to constantly go and log in and cross off problems that had been selected by students or to uncross off problems that students had deselected. And so I really feel like that this doodle poll is the way to go. There are, I'm sure, other ways to provide this list of problems to students too. So Maria comments that the 6-minute allowance would be kind of tight for word problem applications. And yeah, Maria, you're absolutely right. At this point in the semester, usually these problems are where students are fairly comfortable with the content already. And so for these types of word problems, I ask my students to really show the most significant steps of the solution. So maybe they will verbally explain their thought process and then write down the most important steps to the process and not really get too into the weeds with the details. And it's still possible to create a solution in under 6 minutes, but usually I will allow a little bit of leeway in those solutions. But frankly, most of the time, students will be able to solve these problems in under 6 minutes, given that they will have thought out their solution very carefully, and given that I allow them to skip some of the shorter or less significant steps in the solution. And I will point out that usually at the beginning of the semester, it's very clear that the students may not be particularly comfortable or confident with teaching the solution to their classmates. And so I will emphasize over and over again in class and in the feedback that I provide to them that they need to kind of assume the role of the teacher or the educator. So they should be facing the camera at, if not at all times, then throughout their video, so that they make eye contact with the camera and do not talk to the whiteboard, but are addressing the camera and addressing their audience at the same time. So by the end of the semester, the students are really behaving just like teachers. And I've actually noticed that several of my students have requested access or copies of the videos that they have made, so that they could submit them as into like a job application, as far as the or even as a component of a teaching portfolio, so that they can demonstrate that they can teach, so that they can just demonstrate effectiveness of their teaching to future employers and in job interviews. So these videos that they make, they actually keep them as part of their teaching portfolio in the event that they want to go on and become teachers themselves. So by the end of the semester, many of my students are becoming very, very good at these teaching videos, and are using their videos as part of their portfolios and as part of their job applications too. Yes, and Maria remarks that, yeah, another sort of bonus or added value to this assignment is almost like a teacher training, or a teacher preparedness session, where students learn how to be teachers, and I think it really improves their teaching skills. And I've seen this time and time again, actually in class towards the end of the semester, when I call on students in class, their communication skills have improved, and they're able to convey their thoughts to me and ask questions very, very, very well, and very, very well organized, and they're much more confident in class too. And let me just kind of quickly point out what the purpose of this slide of my presentation was all about. So this paper down here by Ellis, Hansen, Nunez, and Rasmussen, they published some characteristics of homework practices at some very good mathematical colleges, I think here in the US. And they documented different characteristics of these successful homework practices. And I tried to demonstrate that these video assignments also align well with these characteristics in terms of structure, content, and feedback. So Athanasia writes, do the video assignments help you spot students that have not understood the solutions and may need further help? Yes. To be honest with you, I hadn't really thought of it that way too rigorously, but yes, at least in sort of on-campus face-to-face classes, many times the students who may not be particularly confident in their abilities will come ask me during office hours to check their solution. And even though I only require the first video assignment to be rehearsed in front of me during office hours, many times students will come to office hours and ask me to kind of watch them practice their solution so that I can catch any sort of mistakes or clarify or explain any of the steps that they may not fully understand. This gives them a little bit more confidence for their videos. And many times these are the students that don't quite have that confidence or aren't quite comfortable with the material yet. And in class, I'm not sure if I can easily spot the students that need further help, but I can certainly spot the students that are really feeling the benefits of these video assignments. And so students that may have been a little bit uncomfortable, a little bit less confident in the beginning of the semester, really develop and are much more confident towards the middle and end of the semester. And, and another thing that I have recently, um, well, I guess recently implemented is that at the start of my classes, my face-to-face class with my students on campus, um, I might um, I might show one of my students videos that have already been posted, and I call it the video of the day. And that way, students who either haven't submitted their videos yet, or maybe are just beginning, reviewing for a test, will see one of these videos during class, and they can see what an example of a video that the instructor finds good and appealing. So students will be able to see an example video that I like and that I'm promoting in class, and kind of use that as a template to kind of base their own videos off of. And I should point out that for some of my classes in which I use these video assignments, particularly for the math classes, not only will I participate in the class introduction videos where I'll introduce myself and go through that list of icebreaker questions, but in some cases I'll even upload and create and record my own video assignment where I demonstrate a solution to a problem in the textbook. That way students can see an example of what a video should look like, and then they have an example of what I have in mind as far as what I expect them to do with their own videos. And I find that students think that that's also very helpful too. So in other words, there's ample opportunity for the instructors to participate and belong to these video assignments as well. Well, good question, Maria. So Maria asked, how do you factor in, I guess, as the instructor, the added workload for supervising and assessing these videos, especially if classes have upwards of 25 students or so. So I think that's what you're asking. And let me just admit that, yeah, this type of video assignment does place an additional burden on the instructor, and it requires a little bit more of a commitment to us than we normally would have. Um, and I guess I would say that assessing and evaluating these videos, once the instructor has seen so many of them, doesn't doesn't take too long to do. So after a while, the instructor will kind of get a sense of what constitutes a good video versus one that needs to be resubmitted. What does take more time is to actually write up and submit feedback to the students, and so that I think that is really the time-consuming element for these video assignments from the instructor. One way, especially in these uh, larger class sizes, one way to kind of reduce the workload on the instructor is to reduce the number of videos that the students will produce. Or, and so in that way, maybe you can divide the class up in half and ask one half of the class to submit videos on this day, and then another half of the class to submit videos on a different day during the semester to kind of taper out the number of videos that the instructor has to assess. And Anna suggests creating videos using small groups instead of maybe pairs of students. So maybe, yeah, that's a great idea too. So this would certainly reduce the number of videos if students work together. So maybe you could have students that would be more than one student on camera at the same time working together to demonstrate the solution. So you could have one student that might write a step in solution, and another student would explain the step, and then vice versa. That's also a good idea too. Very good. I like that idea. Yes, and yes. So Anna writes that the thing is, whenever we teachers focus more on the quality of learning, then we end up having to well, essentially do more work in order to help our students. Yeah, exactly. And I think that's one of the consequences of being an educator, right? Is that if we really care about our students and how they learn, then that effectively means more workload for us. And so we either have to kind of accept that as part of our job, especially if we love our job, or we have to find some way to balance that out. But yes, you're exactly right. And I really like the comments from students on this slide because it really indicates or really signals a degree of planning on the part of the students. So another word for this is self-regulated learning. So the students are really kind of taking responsibility and assuming independence for how they learn and for how they complete this assignment. And many students, you'll notice actually write out a script of how they want to explain the problem, which I think is great because it really helps them put their thoughts on paper and organize their thoughts in a more meaningful and more coherent way. So I just have a few more slides. So again, if you have more questions, please feel free to chat them out, and we can keep this discussion going, or we can um, sort of call it quits too. Sure, yes, and please feel free to contact me afterwards if you would like. Here is my email address, and then here is my academic website too. And frankly, like I said, I would certainly love to hear ideas and suggestions for how to improve this technique or ways to take it forward and more rigorous too. There's certainly a lot that we could do here. Certainly implementing this in classrooms, not just in mathematics, but in English and in humanities would be very helpful. But if any of you decide to look at this more formally as part of some sort of educational research project, then please let me know because I'd be interested in either participating with you and collaborating or in seeing your results. Well, great. Well, it sounds like many of us have to go. So, like I said, please let me know if you have any more questions. please feel free to email me your questions or comments. I'd love to hear from you. So with that, I will also sign off and say goodbye and say thank you again for joining me, and say thank you again to Julie Ann Syme and Carissa Temelis for organizing the session. I personally found it very helpful, and I'm very happy that I was here to present this material to you. Thank you so much, and goodbye from Athens and goodbye from Finland.